Hello, welcome. We are still looking at resultant of forces, but in this lesson we are looking at applications of resultant of forces. There are some ways they can ask you questions that you need the knowledge of resultant of forces to solve those questions. So we are looking at this example of such questions under the application of resultant of several forces or resultant of forces. Now the question is, an object of mass 12 kilogram is suspended from the end of a wire fixed to a ceiling. A horizontal wire attached to the object exerts a pull which keeps the wire at an angle of 54 degrees to the horizontal. Determine the tension in both wires. An object of mass of 20 kilogram. That means there is a ceiling. Let's say this is the ceiling. An object of mass 20 kilogram. This is the object. The mass of the object is 20 kilogram. It's suspended from the ends of a ceiling. This is the wire. This is the object. Now, a horizontal wire attached to the object exerts a pull which keeps the wire at an angle of 54 degrees to the horizontal. There is another object attached to the wire which exerts a pull. That means this object is no longer here now. There is another wire that exerts a pull in this direction. That means this tension is no longer like this. The object is now something like this. So it's not like this. Because this wire has been exerted. Now a force has been exerted on this one. Instead of the wire to be straight like this, it's now bent like this, which keeps the wire at an angle of 54 degrees to the horizontal. This is the horizontal. Keep the wire at an angle of 54 degrees to the horizontal. Determine the tension in both wires. There is a tension in this wire that is keeping T1, that is keeping the object, that is used to sustain the object from the ceiling. And there is this one also, this other wire. Let's say the tension is T2, that exerts a pull to this direction. So this is the diagram of the question. An object is supposed to be suspended like this. Assuming there is no this exert force is not there, the object will be suspended straight like this. But because after the suspension like this, then there is another wire that exerts a pull to this direction. So instead of the wire, the board to be like this, it's now like this. So there is an angle. This wire form an angle of 54 degrees to the horizontal because of this pull of this force. And if you recall that the weight of the object will be acting downward. This object, the weight W, will be acting downward. And recall that W, weight of an object, is given by mg, that's mass times acceleration due to gravity. Then this is our diagram. Then how do we determine the tension in this string and in this wire, the first wire and the second wire? Now I'll first complete this triangle. I can complete this triangle by drawing a line like this. Then I'll find my horizontal and vertical axis. This triangle like this now, I can find this vertical, find the horizontal. If I bring this triangle out, I will have something like this. This place is the 54 degree. This is T1. So that's the diagram. Then in that case, how will I get here? How will I get here? Don't forget that this place will be 90. Now this is a right angle triangle. Now if I consider this angle, the side that is facing this angle will be my opposite. The side that is facing this 90 is my hypotenuse. And this remaining side is my adjacent. So I want to look for this adjacent and opposite in terms of this tension. I'm looking at adjacent and opposite in terms of this tension. Now if I consider this and this, opposite and hypotenuse, which of the trigonometric ratio combine opposite and hypotenuse? Which of the trigonometric ratio combine opposite and hypotenuse? From our SOHCAH2. SOHCAH and 2. That means opposite over hypotenuse is what? Sine. That means opposite and hypotenuse is sine. Then using that, I will have sine 54 is equal to opposite, which is this place now, over hypotenuse, which is T1. Then I will have opposite will now be equal to T1 sine 54 degree. That means this opposite now, which is this place now, is T1 sine 54 degree. That means this place is T1 sine 54 degree from this place now. And how do I get my adjacent? Adjacent and hypotenuse is cos, CAH. So it's opposite and hypotenuse. Cos is adjacent and hypotenuse. 2, which is tan, is opposite of adjacent. So I have adjacent and hypotenuse. That's cos, adjacent and hypotenuse. In that case, I will have cos, which is cos 54 degree, is equal to adjacent over hypotenuse. Then adjacent over hypotenuse, that means I will have adjacent now is equal to, let me write it, cos 54 is equal to adjacent over T1. That is adjacent now will be equal to T1 cos 54. That means this my adjacent is T1 cos 54, which is this place. And you know that this place is equal to this place. This place is equal to this place. So this force, this place will now be T1 cos 54 degrees, because this place will be equal to this place. Because this is a rectangle and the parallel sides are equal. So from here to here will be equal to from this place to this place. So this is T1 cos 54. Now, you recall that upward force, this place is upward force, will be equal to downward forces. So to get my T1 now, I can use upward force is equal to downward forces. That means in that case, my T1 sine 54 is equal to W. Upward force is equal to downward force. So T1 sine 54 is equal to this W. And W is equal to mg. So I can have T1 sine 54 is equal to mg. Then the m, mass of the object, is 20 kilograms, whereas our g is 10 meters per square second. This is our mass, this is our g. So if I substitute here, I will have T1 sine 54 is equal to 20 times 10. So T1 sine 54 is equal to 200. Then my T1, tension in the first string, will be 200 over sine 54. So my T1 should be equal to 200. You have 200 divided by sine 54. That will give me 247.2 Newton. So the tension in the first string is 247.2 Newton. Then how will I get the tension in the second string? Don't forget that this T2 will be equal to T1 cos theta. Rightward force is equal to leftward force. Rightward force will be equal to leftward force. So my T2 will be equal to T1 cos 54. So in that case, I can have, let me do that one here. So you have T2 is equal to T1 cos 54. Rightward force is equal to leftward force. In that case, my T2 now should now be equal to my T1 is now 247.2. So I will have 247.2 cos 54 degrees. And you have T2 should now be equal to 247.2 cos 54. That will give me 145.3. 145.3 Newton. So this is one example on the applications of resultant of forces. So these are some of the ways they can ask you questions that require you to use the knowledge of resultant of forces to solve. So this is the set out. Look at the way the set out is very neat. So you can subscribe to our YouTube channel at Physics with Chris. More examples are still coming on these applications of resultant of forces. Subscribe to our YouTube channel, turn on the notification button so you can get our videos as soon as we are dropping them. So watch out for more examples.